Okay, in this video we're going to talk about how to graph the first derivative and the second derivative on the same graph with the original function. So let's do your classic original function. So it's going to be something like, we'll do a little bit of a cubic, I guess. Okay, let's just say we have something like that. Okay, so the black is my f of x. Let's draw f prime of x on the same grid. So we need to get some landmarks. One landmark is right below the max of the original function. The max of the original function has a slope of 0. Therefore, the value of the first derivative will be 0 right at that same x. Same thing with the minimum of the function. The slope right at the minimum will be 0, and therefore the function value of f prime of x will also be 0. Next, we want to check out the inflection point. Let's just say, for argument's sake, that the inflection point was, let's just say it was here. That inflection point is the most negative section of your original function, and therefore its slope is negative. So to denote a negative slope, I'd have to be reading values from below the x-axis. So I can now sketch my second function, which is the f prime of x. Let's change to yet another color, and let's talk about how I would possibly sketch the second derivative. Look at your first derivative and look where the minimum is. The slope of the minimum is 0. Therefore, right at that same x value, so right in between these 2 points, that's going to be a value on my second derivative. So then the question is, looking at the original function, I see that it is concave down from negative infinity up to the x value of that blue point I just put on. If it's concave down, the second derivative must be negative, and therefore I draw the second derivative line below the x-axis. Where the function's concave up, the second derivative is going to be positive. So here is the sketch of my first and second and third derivative, first and second derivative. I could go ahead and get a third derivative just by knowing that the slope of my second derivative is a constant. It's a constant that happens to be positive. So I could do the third derivative. It would be a horizontal line. And then you can draw that on there as well. So we can keep going as long as there are derivatives to be taken, we can take them. Let's for a moment talk about some of the characteristics you want to have always in the back of your mind. Your original function, it has varying slopes. Depending on what x you pick, you have a different slope. So those slopes are identified on your f prime of x function. Your f prime of x has the job of giving you every slope that you need. So if I draw a tangent line to my original function right here, here's a tangent line touching it in one place. What's the slope of that tangent line? Well, as long as I have that first derivative, I can see the slope is positive. To get the exact value, you take the point of tangency and go to the next curve. So take it up to the f prime of x curve. And then you're going to read over that y value will give you the value that is the slope of the brown tangent line we just drew. Okay, so we'll do another one like that. What if instead I want to get the slope of the function at this point over here? I can see it's also positive. I'm going to draw either up or down to the f prime of x function and then read over to the y value to get the slope value. Because the red function's above, I'm going to go up, hit the red function, and then go over, and that y value that I'm getting is going to be the value of the slope of the original equation, original function, where x is that value right here. Okay? We could do the same thing determining the relationship or describing the relationship between the first derivative and the second derivative. The second derivative is functioning as the slope of the first derivative. So, for example, if I am here on my first derivative and I'm wondering what that slope would be, what I would do, and I'd have to extend my blue line a little bit, so let's just extend that line. What I'd have to do in order to get my slope value is to take this x value and take it up to the second derivative and then read over that y value, whatever it might be, is the slope on the first derivative at point x. Okay? So, a slope and a derivative are the same. The first derivative is the slope of the original function. The second derivative is the slope of the first derivative. All right? Lots to remember, but just keep working at it.